Hi everybody, this video today is going to talk about lesson 7.3, which is solving systems by elimination. So once again, we have over here on the left, we have an example worked out, but I'm going to do the example on the right and kind of talk through as I go. One of the main things about elimination method, well, first of all, another word for elimination method, another way to say it is combination method. So sometimes I might say linear combination, and what I'm talking about is elimination. Those two are the same thing. One thing is you look at the coefficients. The coefficient is the number that's in front of the letter. And you look at that and you make sure that it's an opposite coefficient. That means it's the same number but a different sign. Okay, so let me show you what I'm talking about. I'll do this one and then we'll talk about this a little bit more in the next example. If I look at this, I have a 1x and a 1x, and I have a negative 1y and a positive 1y. Because remember, if there's not a number in front of it, there's actually a 1 there. So there's a 1 on each of these and a 1 on each of these. And so as I look at this, I see that the y's have opposite coefficients. That is, they are the same number but different signs. And so what that means is I can just add my equations straight down or combine them because of the combination method. So I combine these. I'm just going to add these equations straight down. So 1x plus 1x is 2x. My negative 1y and positive 1y adds up to 0, so it's gone. And then on the other side, I have a 24. Now I just need to solve this equation. That's pretty easy to solve, right? I just divide by 2, and I get x equals 12. So there I have my x. Of course, I have to find my y also. And we do that just like we were doing it in the other method. So we have to take that 12 and plug it back into one of the equations. Does not matter which one. I'm going to pick equation number 2. So I'm just going to plug it into that second equation because it does not have negatives, so I think that's a little bit easier. So that's going to give me x plus y equals 14. My x is 12. My y is what I'm looking for. So I plug in that and I subtract 12 from both sides and I get y equals 2. So my answer should be 12, 2. And that's my final answer. Now I do want to check my answer. I always have to check my answers. So equation number 1 was x minus y, that is 12 minus 2. Does that equal 10? Well, yes, it does. And the second equation was x plus y equals 14. Oops, I was going to sub in. That's okay, I'll sub them in now. 12 plus 2 equals 14. Does that? Yes, it does. So yes, it does check out in both answers because it makes both equations true. Let's try another example. Okay, remember what I said about opposite coefficients. That is the same number but a different sign. And so we're going to only do one of these just for time. I want to show you though, number 1 already has the same number and different sign with the y. I'm not going to do this one the whole way, but I'm going to show you how I'm going to start it. I'm going to add these together. That's going to give me, remember this is a 1y, so that gives me a 3y. My 3x and negative 3x add up to 0, they're gone, and this adds up to 12. So if I divide by 3, I get y equals 4. And then, of course, I'm going to plug that in. I'm going to find the x. Okay, but I want to focus in on problem number 2. Because the deal with problem number 2 is that we have a 4y and a 4y. But the problem is they're both positive. You're supposed to have one of them be negative, and it's not. And so there's a couple ways we can do this. One way is we can think that we're just subtracting it. Another way that I kind of like better is say, let's multiply this by negative 1. And so we're going to multiply all 3 parts by negative 1. And when I do that, that's going to be a positive 2x minus 4y equals negative 10. All we did was basically change the sign on all 3 things. Now my top equation, I'm going to keep it just like it was. 5x plus 4y equals 17. Okay, so when the numbers are the same number but different sign, or excuse me, same number and same sign, you have to multiply by negative 1. And then you're going to add these together. And so this is going to come up to be 7x. These add up to 0. And here we get a 7. Divide by 7 and we get x equals 1. Of course, we have to take that 1 and plug it in. I think I'm going to pick the top equation. I like to avoid my negatives. So that's going to be 5 times 1 plus 4y is equal to 17. I'm going to solve for y. So 5 times 1 is just 5. I'll subtract 5 from both sides. So that's 4y equals 12. Divide by 4, and I get y equals 3. So my final answer should be 1, 3. I'm going to check my answer by plugging it in. I'm kind of out of space up here. It's kind of crowded. So I think I'm going to just come over here and do it. So 5 times 1 plus 4 times 3, does that equal 17? Well, that would be 5 plus 12. Yes, it does. Okay, the second equation, negative 2 times 1 plus 4 times 3, and does that equal 10? Well, that's a negative 2 plus 12. Yes, that does equal 10. So my answer does check out. Let's turn the page. Okay, on the back side, the equations don't match up like they were on the other side. Like on the other side, it was very easy that the y's matched up or the x's matched up. On this side, they don't. But then we have a process for that. If they don't match up, then you just have to multiply the equations to make them match. And sometimes we call that scaling the equations. So in other words, if I look at these numbers, I'm going to look over here, 5x, 3y. Well, one's negative, one's positive. That's good. But the 5 and the 3 don't have anything in common. I'm going to look at my y's. I have a negative 2y and a positive 6y. Well, one thing, again, one's negative, one positive. That's good. 2 and 6, they have something in common. I know that if I multiply 2 times 3, I would get 6. So I'm going to multiply 3 times this whole equation. And I'm just going to come right over here like I did on the other one. So this is going to give me a negative 15x minus 6y is equal to negative 42. Now, you might have to get your calculator, but 3 times 14 is 42. The bottom equation I'm going to keep just the same, just like I did on the other side of the paper. So that's just 3x plus 6y is negative 6. I'm going to add these together now. Because again, my idea was to get these to have the same number but different sign. And I do. I have a 6y and a positive 6y and a negative 6y. So this is going to work for me. Okay, so I'm going to add these together. That gives me a negative 12x. The y's are 0, gone. Here I have a negative 48. I'm going to divide by negative 12. And I get my answer of positive 4. Okay, x is positive 4. Now, to find my y, what do? I plug it in. So I'm going to plug it in, avoiding the negatives as much as possible. I'll choose equation number 2. So that's going to be 3 times 4, x is 4, plus 6 times y equals negative 6. I just got this equation right here, and I brought it down. Plugged in a 4. So that's 12 plus 6y is negative 6. I'm going to subtract 12 from both sides, and I get 6y is negative 18. Divide by 6, and that gives me y equals negative 3. Of course, I want to check my answer, and I'm going to do that in this space down here. So equation number 1 was negative 5 times x, which is 4, minus 2 times y, which is negative 3. And the question is, does that equal negative 14? So that's a negative 20. Negative times negative is positive. And yes, that is negative 14. So that one works. I'm going to go to my second equation. And that's 3 times x is 4, and then plus 6 times y, which is negative 3, is equal to negative 6. That is 12 minus, because the negative times positive is negative, 18. Does that equal negative 6? Yes, it does. So my answer does work. The correct answer is, I haven't written it anywhere, I need to, my answer is 4, negative 3. So that's my final answer. Okay, once again at the bottom, I'm not going to do both of them, but I'll do one of them. I will mention on number 1, anytime there's just a plain old y or a plain old x, that makes it super easy. So I like to choose the one that already has one positive and one negative. So I would choose my x's because they're already a positive and a negative. And I would multiply this bottom equation times 2. I'm not going to do the whole thing, but I'm going to get it started for us. Top equation just stays exactly like it is. Nothing changes. Bottom equation, I multiply everything times 2. So negative, oh gosh, I messed up. I want to multiply times positive 2, not negative 2, because I want those to be opposite. You'll see. So I multiply that, that gives me a negative 2x. And then 2 times 3 is 6y. And 2 times negative 12 is negative 24. Okay. Now, see why I did the positive is because now these are the same number but different signs. And that's what I want. So I add these now, I get 7y. Add these and I get negative 21. The x's, they dropped off. They added up to 0. I divide by 7 and I get y is negative 3. Now once again, I don't have to go back and finish the rest of the problem, but at least that's how you would start it. Now number 2 is not as direct. I just feel like when there's just a plain old x or a plain old y, it makes it so easy. This one doesn't have any of that. We have to look at the coefficients. That's okay, we can do that. So 4 and 5, yes, one's positive, one negative, and these are positive and negative. But 4 and 5 don't have anything in common with each other, so I'm not going to choose that. I'm going to choose my x's because I know that all I have to do is multiply 2 times 3. That's kind of like what I did up above earlier. Just multiply times 3 and you'll get the right answer. So the top equation does not change. It stays exactly like it is. Bottom equation, I multiply all 3 parts times 3. So that's 3 times 2 is 6x. 3 times negative 5, that's going to be a minus 15y. And 3 times 2 on the end is also 6. Okay, this is going to be one that kind of has something tricky in it. Not too tricky. It's not hard, just unexpected. So I add these, my x's, add up to 0. My y's, 4, positive 4 and negative 15 is a negative 11y. Negative 6, I didn't write this very clearly. I always have a hard time with equal signs. That's just part of the equal sign. So negative 6, positive 6 adds up to 0. That's the tricky thing. People sometimes freak out about 0. Don't freak out about 0. Nothing freaky. So divide this and you get y equals 0 divided by negative 11. You can do it on your calculator. It'll tell you that the answer is 0. Now, of course, I have my y. What do I need to do? I need to find x. Choose either equation. Neither one of them looks very good. I'm going to choose equation 2. They've both got negatives. None of them are solved. Let's just do number 2. So 2 times x minus 5 times y, which is 0. Now I can do that. I can plug in a 0. So that's just 2x minus 0, or it just goes away, 2x. 2x equals 2, divide by 2, and I get x equals 1. So my final answer should be 1, 0. Of course, I always want to check my answer. So I'm going to. First equation is negative 6 times 1 plus 4 times 0. Does that equal negative 6? Well, yes, because this is a negative 6 plus 0, and yes, that does equal negative 6. Equation number 2 is 2 times x, which is 1, minus 5 times 0 is equal to 2. And that's going to be 2 minus 0 is equal to 2. Yes, of course, 2 minus 2 is 0. 2 minus 0 is 2. All right, so that is how we do elimination method when you have to multiply by one thing. When we come to class, we'll do some practice on this.